Hello students, how are you? Today we are going to study a new series of videos and the purpose of this is to clarify some numericals and some concepts as well as tricks in that. Today we are going to see what constraint motion is. Not in details, we are going with the assumption that last year you have completed this already. So instead of going into very fundamentals of this, we will be doing some numericals, and while exploring those numericals, so we will also use some tricks, and where from those come from tricks and the concepts also will read. And our focus will be, there are many constrained motion. Okay, how a pulley is constrained. There are fixed pulleys, there are movable pulleys. These two movable pulleys we'll see in numericals, and how the pulley motion is being constrained, those things we are going to see. And some fundamentals about pulley problems we are aware of, but for a quick recap, I remind you those things. Let us say this is a pulley. Okay, then a smooth string passes over it. Let us say two masses are hanging from it. Let us say this is M1 and this is M2. So these type of question is the very basic, very fundamental level of question from the area of pulleys, constrained motion. See, basically what constrained motion is of a system. If the motion of a part of a system is dependent on the motion of another part of the system, we call the motion is constrained. For example, let us say there is a wall and there is a ladder here, let us say. Now of the ladder, there are two tips you are saying, this tip and this. Let us say this tip is A and this tip is B, and this is falling like this. Let us say this ladder is coming down like this. So A is coming down with some speed and B is going in this direction with some speed. Now the thing is, there is a constraint. Constraint means a binding condition. See, whenever B moves, whenever A moves down, always the distance between A and B has to be constant, right? The length of the ladder is constant all the time. So whatever B is not very free to move, but it has to move in such a way that the conditions should be met all the time. That is, the distance between A and B has to remain constant. This is a constrained motion. That is, a part of the system, the motion of a part of a system is dependent on the another part of the same system by some condition. So it's a binding condition. When we say constraint, means it's a binding condition. So we are not going to make it a theoretical video. So we are going to explore into some numerical today, and with the assumption that we have already completed these things in the first year only. And so suppose we are taking up this scenario. This is the simplest possible scenario as far as the pulley problems are concerned. Let us say M1, M2 are there, and the pulley itself and the string passing through that is always a massless, negligible mass. That's our assumption. Now there are two type of questions where this pulley is fixed to a clamp. This is a fixed end, and fixed by a clamp or fixed by a thread. Okay, now just to make a little better assumption, so we will make it a thread only. Okay, now see, in a single string, tension will be the same. Let us say tension is a T of the string. Now if we are drawing the free body diagram of M2, then M2G is downwards, M1G is downwards. Now if we are applying the free body diagram, equations of free body diagram to M2, how it will be? m2g minus t is equal to m2 multiplied by a. Now let us assume that m2 is greater than m1, that is m2 is heavier than m1. Now this is purely one assumption. Okay, now between these two, one is going down, and with what acceleration is going down? With the same acceleration going up. So m2 is going down with acceleration a. If this is our assumption, m1 is moving up with acceleration a. That also, because that is the reason it's a constrained motion. If m2 is going down with acceleration a, m1 must go up with acceleration a. So this is the assumption. Now suppose m1 m2 are not given in the question, then you will be asking how you are assuming that m2 is greater than m1. M1 could be greater than m2 also. That's right. But the thing is, with some assumption, if we if we'll get one answer, for example, a is downward we took. When we calculate, if a comes minus 2 meter per second square, let us say, then we'll assume that since this minus sign came, that means it's a 2 meter per second square is the magnitude, but opposite to our assumption. If a comes minus 2 meter per second square, if a comes plus 2 meter per second square, we will say that it is going down with 2 meter per second square. If a is equal to minus 2 meter per second square, it's moving up with the acceleration 2 meter per second square. That we will say. Okay, that also you already know that thing. So with these assumptions, we are putting the free body diagrams. This I am doing only for a quick recap. Okay, this also is the pre-requirement to go into numerical. So m2g minus t is equal to m2a. Now if we'll put the equation of free diagram to this is moving up. That's why naturally t must be greater than m1g. P minus m1g is equal to mass of the body, what is under consideration, multiplied by a. Now add these two, plus t minus t got cancelled. m2 minus m1g is equal to m1 plus m2 plus m1a. Add these two. Implies that acceleration is equal to m2 minus m1 divided by m2 plus m1 multiplied by g. Okay, now see, in these type of questions, generally it will be asked to find the acceleration of each block and tension in the string. Now acceleration we found. What's the tension? Now simply make some drama. Let us make it equation 1. Now in equation 1 we got the value of acceleration. If masses are known, 1 kg, 2 kg or 2 kg, 3 kg, whatever, if masses are known, we'll put those values and we got it right. So acceleration we got in terms of m1 and m2. Now that value of acceleration, if we'll put in any of these equations, let us say, let us make some drama. This is our equation 1, this is our equation 2, and what came now is our equation 3. Now put the value of a from equation 3 in any one of the equations in 1 or 2 and find out t. For example, in from equation 2 we got t is equal to m1a plus m1g. So m1 into g plus a. From equation 2, t is equal to how much, right? m1g went that side, m1 into g plus a. Now a we got here, put that value of a here and find out the tension. So tension also we found out and acceleration also we found out. Now we are going to say one shortcut trick here. Now see, just to adjust that, I am erasing all these things. Now what we'll do is, now see, this entire system we will think as one system. To make it very quickly, orally, what we'll do, now you imagine that this is stretched like this. This is your m2 and this is your m1, and there is one string between them, and this direction m2g force is there, and in this direction M1G force is there. So what is the net force here? You imagine you have a feeling of this. So one pulley is there, two masses M1 M2 are hanging, you are pulling from both the sides, you are pulling it from both the sides. Then what is the net force on the system if this entire thing including the pulley, if this entire thing is one system, then what is the net force on this? M2G minus M1G, right? Because the tensions will cancel out each other. That's the internal force. So what is the external force on the system? M2G minus M1G. M2 minus M1G. G if you took common. M2G minus M1G divided by what is the mass of the system? Isn't it M1 plus M2 or M2 plus M1? The same thing. This is equal to the acceleration. So now what we did is net force divided by total mass or a net mass, let us say. Net mass. This is the shortcut. Now see, you just saw this figure. You said what is the net force on the system? M2G minus M1G. So net force, total force by M. Here Newton's law we used. F is equal to Ma. So A is equal to F by M. But when F by M you did F net by M net. What is the net F? M2G minus M1G. And what is the M mass of the system? M1 plus M2. So M2G minus M1G by M1 plus M2 is your A. Now if you do this, see A was M2 minus M1 by M2 plus M1G only, right? So this is what exactly you got the same. But this here you put some equations, you solved it and got the acceleration. But here you just orally you said it out. Okay. We will apply this technique. We will apply this trick and we will see how numericals are solved so quickly. But here remember one thing. This for application of a particular thing, to find out the acceleration only this trick is being used. But if the tension is asked, we have to put it in the equation. So taking the tension, one equation we have to make from free body diagram, one equation we have to form, then only we can find out tension. And another thing we have to keep in mind that as long as the pulley is fixed, then only this shortcut trick will work. If the pulley itself is moving, we have to apply some other trick. We will be discussing that later. Here I forgot to tell one thing and let me cover that up now. See, here there was a pulley. Here there was M1 mass was there, M2 mass was there, and in this case we could find out the tension in the string. Now, what is the direction of a tension? There students are generally confused. You remember that whichever point we are taking for reference, from there tension will be always away. For example, let us say there is one thread like this. Now you are, let us say AB is a thread. Now at A and B you are holding and pulling it apart. Okay, you are pulling it with some force and with the same force or some other force. You are pulling it up. Let us say F1, F2 or FF. You are pulling it aside. Now what is the tension in the string? Tension at any point. Here if you will say what is the tension. Now the trick is always consider yourself sitting at the point where you want to know which side is the tension. When you sit at it, tension will be always away from you. So now see, this side it will be away from you. This is the direction of a tension. Now this side you will be always pulled this side also, and this side also you will be pulled, right? So tension will be in this direction. Now the thing is, in a rope, what is the direction of a tension when you ask? In this direction also, in this direction also. Throughout the string, tension will be same only, and its direction may be towards this also, towards this also. But it is towards this or towards this, that will depend on which point you are deciding. For example, see here, if in this equation, if we are drawing the free body diagram for M2, from M2, you imagine yourself sitting at M2. From M2, tension is away from you, so it is upward. But if the pulley itself is a reference point, then from pulley's point of view, it is downwards. So tension will be downward. From M1 perspective, tension is upward. You understood the concept, right? Now see, from the pulley's perspective, if tension T and T are downwards and the pulley is not moving, right, it is fixed. So it must be balanced by this 2T or 2T are downward. So it must be 2T upward, right? And if this is 2T upward, from the point of this fixed end is down, 2T is downward. So 2T upward from pulley's point of view, from this fixed point 2T is downwards. Now why I said this concept, in some questions what we solved previously, I erased that already, there the tension in the string may be asked, and in some similar question this pulley also is tied with a thread to the fixed end. What is the tension in the fixed thread? This also may be a thread in some questions. So here also tension may be asked. So by calculation what tension we got, that has to be multiplied by 2. 2T will be the tension over here. Fine. So let us take this question which says, in a simple etude machine, this is called etude machine, two unequal masses M1 and M2 are connected by a string going over a clamped light smooth pulley. In a typical arrangement shown in the figure, M1 is equal to 300 gram and M2 is equal to 600 gram. So let us take up this question which asks this simple arrangement of a pulleys are there. Now M1 is given to be 300 gram, M2 is given to be 600 gram. It asks distance traveled, calculate the distance traveled by the first block, that's M1 block, in the first 2 seconds. What is the distance traveled is asked. Second question asked, what is tension in the, find the tension in the string, T is equal to how much is the question. And the third question is, find the force exerted by the clamp on the pulley. Now see, the concept what I said is, if this is T, this is T, then downward will be, so this is T, this is T, so this also is T, this is T, so in here tension will be 2T. Okay, now let us take up this problem, HC Verma question number 22. This in the free this pulley arrangement, here M1 M2 are there. Now there will be a tension in the string, right? Let us say tension, that tension is T, then this T will be, and the tension in this thread, that is between the clamp and the pulley, that is 2T, right? So what is asked in the question, distance traveled by the first block, that is distance traveled by M1 in the first 2 seconds. What is the tension in the thread and the force exerted by compared by the pulley? That's why it must be 2T, right? So it will be double of that. So this is the question, the answers are written in red, we are going to solve it. Okay, now see, M1 is 300 gram, M2 is equal to 600 gram. So M2 is greater than M1, right? So naturally M2 will go down, M1 will rise up with some acceleration, we don't know, right? Let us say it's going down with acceleration A and M1 is rising up with acceleration A. Now see, tension in the thread is T, and that is the reason T, 2T, and this side is 2T. The question asked, force exerted by the clamp on the pulley. Force exerted by the clamp on the pulley will be 2T. So 2T is equal to how much is the C question, T is equal to how much is the B question. The first question is, what is the distance traveled by M1 in first 2 seconds? M1 means this is a 300 gram block. 300 gram means in SI unit if you will write 0.3 kg, and this is 0.6 kg. Fine. Now see, what are the forces acting over there? Let us apply that a shortcut trick. What I said is the net force divided by net mass is the acceleration, right? So acceleration is equal to force net. Here there will be m2g and here there will be m1g, right? So acceleration is equal to, what is the net force? m2g minus m1g, m2 minus m1 into g. So m2 is given 600 minus m1 300 into g divided by total mass 600 plus 300. Now please understand that this is if we'll make gram minus gram, it will come in gram only, and this will come gram only. Gram will get cancelled, so no unit. If you make it kg also, numerator denominator both are kg also, it doesn't matter, right? Kg will get cancelled. It is the same thing only. So instead of making it 0.3 kg or 0.6 kg, I wrote it just like that. So 600 minus 300 is 300 g divided by 900. So g by 3. So acceleration is equal to g by 3. We got, right? Now, but acceleration is not asked. Distance traveled by the first block in the first 2 seconds. Now from equation of a kinematics, you remember S is equal to, we can apply ut plus half at square. Now what is the distance traveled is the question. Therefore S is equal to, it started, it is released somewhere, it's given, means it just started, means u is equal to 0. 0 into, in 2 seconds it is asking, 0 into 2 plus half of a is how much we got, g by 3 into t square, 2 into 2. 2 got cancelled, so it's equal to this 0, right? 2g by 3. And approximately if we take g is equal to 10, so this is equal to 6.6 meter. The answer comes 6.5 meter, it's nearly right. We'll be taking up the second, what is tension is asked. What is tension now? Once we got the acceleration, then tension is equal to how much? You solve the free body diagram of this part. Since this is coming down, m2g minus t is equal to, m2g minus t is equal to m2a. Yes or no? You can put this also. Free body diagram of this, t minus m1g is equal to m1a. This also you can put. You will get the same answer with the same time only. So m2g 0.6 into g is approximately 10 you take. So 6 it became, right? 6 minus t is equal to 0.6 multiplied by a. A is g by 3. G by 3, right? Implies that 6 minus t is equal to, g approximately take 10. So it is 6 by 3, which is equal to 2. Implies that t is equal to 6 minus 2, 4 Newton. Approximately for g we took 10, if we take 9.8, this will come exactly 3.9 Newton. We got 4 Newton because we took g. So 3.9 Newton. Now from the understanding we have already said that if this is t, then the force exerted by the clamp on the pulley will be 2t, twice of that, so 7.8 Newton. Now see, if this question is there, some multiple choices are there, how quickly you solved, you understood, right? By short tricks, you find out the acceleration is equal to net force m2g minus m1g by m1 plus m2. You did, you find out the acceleration. Then you put 1 m2g minus t equal to m2a, you find out the tension, made it double, wrote it. So it's not a very big question, immediately solved, right? Now let us take up this problem where it says two masses m1 m2 are connected by a light string passing over a smooth pulley. Masses m1 m2, so how we discussed initially, like that similar arrangement is taken. So let us say this is a pulley. Two masses m1 m2 are connected by a light string. When set free, m1 moves downward. So m1 is naturally, it's indirectly given, m1 is greater than m2, right? So this is m1 and this is m2. Now let us say m1 is moving down with the acceleration a and m2 is moving up with the acceleration a. Fine. And it moves, m1 moves downward 2 meter in 2 seconds. So naturally it will be m2g is downwards and m1g is downwards. The tension are upwards, right? Now it moves 2 meter in 2 seconds. Applying equation of a kinematic, S is equal to ut plus half at square. 2 is equal to, since this is set free, means u is equal to 0. 0 into 2 second plus half of a multiplied by 2 square. 2 into 2. So 2 got cancelled, 2a, this is 0. Implies that a is equal to 2 by 2, 1 meter per second square. So m1 is coming down with 1 meter per second square and m2 is moving up with 1 meter per second square. Acceleration is 1 meter per second square. Let's make some drama. Let's make it equation 1. Now, what is the shortcut? Acceleration is equal to F net by M net, right? So, what is F net? M1G minus M2G, M1 minus M2G divided by total mass M1 plus M2, M1 plus M2. Sure. Now, A is equal to 1 implies that put A is equal to 1. So, M1 plus M2 multiplied by 1 is equal to M1 minus M2 into G. Implies that M1 plus M2 divided by M1 minus M2 is equal to G. Implies that divide both the parts by M2 because our intention is to find the ratio M1 by M2. So M1 by M2 plus 1 divided by M1 by M2 minus 1 is equal to G. Implies that take M2 LCM here, or you multiply this thing M1G. See, if you take L2 LCM here, again this will come, right? But M1 by M2 bringing this ratio is our intention. So M1 by M2 plus 1 is equal to G multiplied by M1 by M2 minus 1. Is it visible to you all? So let me write it here. I am erasing this portion. So from here if I write, see G M1 M2, if you bring it this side, if you take common M1 by M2, if you take common 1 minus G is equal to G minus G is there plus 1 minus 1. So minus G minus 1. Am I correct? M1 by M2. Directly I am doing it, right? So M1 by M2 minus G into M1 by M2 will come this side. So M1 by M2, when you take common, 1 minus G remain, and this minus plus 1 will go that side, it will become minus 1, and minus G is already there, minus G minus 1. So implies that M1 by M2 is equal to G plus 1 whole of minus, and if this 1 minus G is there, this also G minus 1. Okay, so approximately taking G is equal to 10, so 10 plus 1 is 11 by G minus 1, 10 minus 1, 9. So this is the correct answer. Clear? Another problem from H.G. Verma, it is question number 25, where there is a structure like this, where it is inclined, and this side is given to be 3 meter. This side is given to be 4 meter, and this side is 5 meter. Pythagoras theorem, right? 5 meter. Now here there is a pulley, and over the pulley a string passes, and that is connected to 2 blocks. Okay, and both the blocks are of 1 kg mass. 1 kg, 1 kg. Okay. Now see, the question is, find the magnitude of the acceleration of the 2 blocks. Let us say options are G by 5, G by 10, G by 15, G by 20. Now see, just looking at this, you pause the video, you apply that a shortcut trick, and without doing any calculation whether you are able to find out the right answer or not, you find out. Okay, so we'll see. Now see, this is 1G downwards, right? If this is theta, this can be resolved into 2 components. If this is theta, this also will be theta, right? Let us say this is theta 1, then this also will be theta 1, right? And let us say this is theta 2. Then here also there will be mg, and this also can be resolved into 2 components. So if this is theta 2, this also will be theta 2. Now this side will be what, right? Mg sine theta 1, right? And this side will be mg sine theta 2, isn't it? Sine theta 2, isn't it? Now apply that a shortcut trick. What is the acceleration only is the question, right? Acceleration is equal to what? Net force on the entire system divided by mass of the net mass, means mass of the entire system. Now you think from here to here as one system only. So what is the net force? Which is greater, you find out, tell first. Theta 1, sin theta 1 is equal to how much? P by h. When you see this, P by h, 3 by 5. So this is equal to m is 1. So 3g by 5. Clear? Now this is mg sin theta 2. Sin theta 2 is equal to P by h, 4 by 5. And m is equal to 1 kg. So 4g by 5. Now from this side it's pulled with 3g by 5, 4g by 5, which is bigger? 4g by 5 is bigger, so it will come down, right? Let us say this comes down with acceleration a and this goes upward with acceleration a. What is that F? Net force, that is equal to, from here if we are saying net force, this is bigger, right? 4g by 5, 4g by 5 minus 3g by 5 divided by 1 plus 1, 2. So this is equal to 5 you take on 4g minus 3g, g by 5, g by 5 into 2. So g by 10, right? So this is the correct answer. Clear everybody? We applied the shortcut trick, and seeing here, this also, these arrow marks also I showed only to make you understand. But if you understood the shortcut trick and your mind is a little fast, that also is not necessary, right? Just to see the ratio P by h, from this side if you will say 3 by 5, from this side if you will see 4 by 5, and then you just found out and got take the answer. Clear? Now take up another question where it asks, there is one table, here a pulley is fixed, there is a mass, here also it's tied to a mass. Okay, now it is given m1 and m2. This is m1, this is m2, and this is pulled this side with a force F. And in the question it's given that F is equal to m2g by 2. Okay, then what is the question? The string and the pulley are light and surface of the table is smooth. Find the acceleration of m1. See, this is another question where you can apply what shortcut you learned just now. So what is the acceleration of m1 is asked. Acceleration of m1 is equal to how much is the question. Now since this is tied by one thread only, then acceleration of whatever acceleration, if m2 is going downward with acceleration a, m1 will go this side with acceleration, same acceleration only, right? Why I took it down? See, if we assume now opposite also, if minus comes we will understand, so that's not a problem. But see, m2g will be pulled down, right? m2g is downwards and m2g by 2 is pulling this side, so this is more, so then naturally it will go in downward direction only. Let us say it's moving downward with acceleration a, so that m1 is moving rightward with acceleration a. Now instead of taking those tension and all these things, instead of taking all those tensions and making out the equations and solving all those things, we can solve just looking at it, because the question is asked only the acceleration. So what is the acceleration? Acceleration is equal to net force divided by net mass, right? So what is the net force? m2g minus m2g by 2. So it's directly m2g by 2 whole divided by, what is the net mass? m1 plus m2. So we can write directly 2 multiplied by m1 plus m2. Here, now this is the magnitude of the acceleration, but it will go towards right, and acceleration is a vector quantity, so we should write m2g by 2 into m1 plus m2 towards right. Clear? Now let us take another question, number 30 of H.C. Verma, where the tension is asked, and the diagram is somewhat like this. There is a table, two fixed pulleys are there. At one end there is one fixed pulley, from here it goes, and the other end there is another fixed pulley. Okay, now from here this pulley is tied to a block, and here also it is tied to a block. So this is a moving 1 kg, and this also is 1 kg. Now naturally there will be a force pulling it down. 1 into G, mg is there, right? So here tension T. Now see, from this point the string comes and the same string continues till here, same string continues. So here also what? The tension will be same only, right? So since this the string is same, tension is same only. Now the question is calculate the tension. The pulley and the string are light and all the surfaces are frictionless. Take G is equal to 10. Take G is equal to 10 meter per second square and calculate the tension in the string is the question. Meter per second square. Calculate tension in the string. Now, okay. Now, what is the tension? You quickly put the equation here. Mg, G minus T is equal to M into A. 1 into A. Now, this is one equation only. But what is A? A we can calculate from the shortcut trick, right? What is the net force? Net force is only G, right? So total net force by net mass, so 2. So acceleration is equal to G by 2. You find this, right? 1 plus 1, 2, and only one force is there. This side no force which is pulling it to this side, right? So only one force, G by 2. A is equal to G by 2 implies that G minus T is equal to, for A you wrote G by 2, implies that T is equal to G minus G by 2, that is G by 2, isn't it? Now if in the question it's given G to be taken as 10, so 10 by 2 is equal to 5 Newton. Clear? See this, if we are putting the equations and write it, that also is not difficult, but it will take a little time, right? Just applying the shortcut trick, how easy it becomes. Immediately you can get the right answer. Clear? Now we will take another question where there is a fixed pole, there is a fixed pulley at the end of a table structure like this, which is of mass capital M dash, and on that there is a small block. There is a block of a small mass M. The question is, what should be capital M? M is equal to how much, so that this small m doesn't slip down. Okay. What else is given in the question? This angle is given to be theta in the question. Okay. Now here there is some concept to be understood. Okay. Now see, we will be doing the free body diagram of this body and this body separately. We are having three bodies, right? Capital M, one body of mass capital M dash, and one body of mass small m. Now since from here to here the string is the same, let us take this tension T. Okay. Now this M will exert some force on M dash, right? That is the reaction on M dash. Let us say that is R. Now if we be having one perpendicular here, if this is theta, this is theta. Is it clear? Why this is perpendicular to this, and this line is perpendicular to the surface. So this is theta. Now if this R is resolved in two components, then this will be R cos theta and this will be R sin theta. Is it clear? This side will be R sin theta, this side will be R cos theta. Now when we will look at the small mass M, then on that what forces are acting? The normal reaction will be, see, that small m is pushing the capital M with the reaction R. So there will be a reaction from this capital, this triangular structure also will push the small m with the R only, right? And that R, if we resolve, let me show that in another color. If that R is resolved in two components, what it would be? Now see, if this is theta means this is theta, this is theta means this is theta. So the above will be R cos theta and this side will be R sin theta. Now this green colored forces, those are the forces on the small block of mass small m, right? This red colored, these things are the forces on the this triangular structure, right? Now let us write the equations. Here there will be mg force downward, right? If we are going to write the free body diagram, equations from free body diagram for capital M, what that will be? Mg minus T is equal to M into A. Now we are assuming that, let us say this is going down with the acceleration A. Now our condition is this M should not slide, right? Then this must go with some acceleration. Let us say that some acceleration is A. Then we should understand that this body will start with the acceleration A only, and along with that, since small m is not slipping, that also is going with the acceleration A only. Clear till now? So write the equations. Mg minus T is equal to Ma. Let us make some drama. Let us say this is equation 1. Now of m days, let us write the equations. Now see, m dash, writing the free body diagram, just to make it clear, let us say this m dash. M dash, on that what forces are being acted, right? One is R and one is a tension in this direction, right? Now this R we resolve in two components. Let us say that become R sine theta, and this is the R cos theta, right? Now see, if we are maintaining the sign from this side, this R cos theta component is what? This R cos theta is getting cancelled, these two things, right? So R sine theta. Now T is going this side. If I am writing, since it's moving this side, T minus R sine theta is equal to M dash multiplied by A. Got or not? Right? Now what is additional things we added to this? One R which is not given in the question, T, capital T, which is not given in the question, small a, it's not given in the question, we assumed. So whatever equations we are finding, we have to eliminate the R, T and A from that. Now see, we got one opportunity to eliminate a T from these two. Just add up these two things. Plus T minus T got cancelled, right? What remained? Mg minus R sine theta is equal to M plus M dash, capital M dash multiplied by A. Now from this R and A also we are going to eliminate. But for that more equations will be required. What more equations we can find? You tell me. Now see, what is this R cos theta? Isn't it equal to mg? And we can also say R sin theta. Isn't it equal to ma? So if we are writing R cos theta is equal to mg and R sin theta is equal to ma, then just divide this by this. What saying this by this? Let us make equation 3 and this is equation 4. Now equation 4 by equation 3 will be equal to tan theta, r will get cancelled, sin theta by cos theta is equal to tan theta, got cancelled, a by g, right? Implies that from here what we got, a is equal to g tan theta, Let us make it equation 5. So a, wherever a comes in the equation, we can eliminate by putting g tan theta. We wanted to eliminate a only. So you remember in this equation for a we can write g tan theta, but r also we want to eliminate, right? Now from here what we'll do, substituting a is equal to g tan theta in equation number, we should put here, right, some equation. Let us say we will not make these equations, we will make this equation 3 and we are not making anything here. So putting, because we have written already, substituting a is equal to g tan theta in equation 3. Put it and dictate mg minus r sin theta. R we don't want in picture. For r sin theta, what we can write? Simply ma, right? R sin theta is equal to ma. From here, r sin theta is equal to ma. For r sin theta, you write only ma, small ma is equal to m plus m into a. Capital M plus capital M dash multiplied by a. Implies that mg, capital Mg is equal to, our ultimate motive is to find out capital M, right? That's why I am making capital M one side. Capital Mg is equal to, take this Ma, that side it's plus Ma, it becomes. So capital Ma plus implies that Mg is equal to, take this side, capital M plus capital M dash plus small m multiplied by a. Here implies that m is equal to capital M plus capital M dash plus m divided by g, and for acceleration you put again g tan theta, g tan theta. So g got cancelled, right? So implies that here one m is there. So capital M is equal to capital M tan theta plus capital M dash plus m multiplied by tan theta. Is it visible? Implies that if we bring this m theta this side, take m common, 1 minus tan theta is equal to m dash plus small m multiplied by tan theta. So from here I am writing, you got it right, from there I am writing here, I am continuing from here. Alright, let me continue from here. Is green visible? I am writing here. Okay, I am continuing in the blue only. From there I am continuing. Therefore, implies that capital M is equal to, now M, capital M dash plus small m multiplied by tan theta divided by 1 minus tan theta, right? So is equal to, divide both numerator and denominator by tan theta, just to make it simplified. M dash plus m multiplied by tan theta got cancelled, divided by 1 by tan theta minus, therefore capital M is equal to m dash plus m whole divided by 1 by tan theta, that is cot theta minus 1. This is the answer. So is this concept clear to everybody? So next video we will come up with the another part where we will be dealing again pulley problems only, but we will introduce a movable pulley and we will discuss some numericals which involve various positions of movable pulleys. So I hope all of you are very eagerly waiting for the next part. Thank you everybody.